On this CRV hybrid, P16E3 is a LIN communication fault involving the 12-volt battery sensor and the ICM. In plain terms, the module may not be getting the battery sensor information it expects. The vehicle may show battery, charging, or hybrid system-related warnings, and the fault area can be as simple as a terminal issue or as involved as the LIN circuit, connected components, the battery sensor, or the ICM. Before troubleshooting, take a minute to review the basic troubleshooting approach. Start with the basic system checks, and use the vehicle's actual failure conditions to keep the diagnosis focused. Before you get deep into circuit testing, check for loose terminals at the 12-volt battery sensor on the 12-volt battery negative terminal. Next, check whether a related battery sensor fault is also indicated. Do not treat that as the main code for this episode, but use it to choose the correct inspection path. Either way, the diagnostic direction starts with the external circuit checks for the battery sensor power and LIN communication circuits. When the path calls for the confirmation check, turn the vehicle to the on mode and wait 60 seconds. That gives the monitor time to run before you judge the result. For the +B sub-audio and LIN bat sensor circuit inspection, prepare the circuit by disconnecting the 12-volt battery sensor connector, the shutter grille connector, and ICM connector P. Work through that circuit inspection with IG mode OFF. On the +B sub audio circuit, the normal condition is 12V battery voltage. On the LIN bat sensor open wire check, the normal condition is that there is less than 1 ohms. Then inspect the LIN bat sensor circuit for a short to ground. The normal condition is that there is more than 1 ohms. If this inspection is abnormal, call it a circuit problem and continue locating the fault in that circuit. If the power supply side of that inspection is abnormal, the next move is the additional power supply inspection to locate the failure. Stay with that branch until the failed part of the power supply path is identified. Once the external circuit has been confirmed normal, move to the components connected to the LIN bat sensor circuit. Disconnect the 12-volt battery sensor connector, the shutter grille connector, and ICM connector P. Then reconnect the shutter grille connector first, followed by ICM connector P, one at a time while performing the inspection. With IG mode off, the normal condition for the connected part internal circuit check is not shorted. This isolation check can be done early because it covers the connected items, but if it fails, keep going through the individual checks to find which item failed. If the fault appears only when a particular part is reconnected, replace the part that's shorted when it was reconnected. For the 12-volt battery sensor inspection, first confirm the external circuit is normal. There is no direct component test for the sensor itself in this path, so the diagnosis is made through the related components and the DTC check. Perform the confirmation check, then check whether the related battery sensor fault is indicated. The normal condition is that it is not indicated. If that check is normal, the path points to a problem with the 12-volt battery sensor. If it is abnormal, the path points toward other related components. For the 12-volt battery sensor circuit inspection, again, start only after the external circuit is confirmed normal. Disconnect the shutter grille connector and ICM connector P, then perform the inspection for that circuit. With IG mode off, perform the sensor internal circuit inspection. The normal condition is not shorted. If this check is abnormal, the diagnostic path calls it a problem with the 12-volt battery sensor. This inspection can also be used early because it includes the related inspection items. But if it fails, continue with the individual checks so you know which part of the path actually failed. If the other inspection items all show normal, the remaining diagnostic conclusion is the ICM. At that point, the path identifies a problem with the ICM rather than the external wiring, the connected LIN components, or the battery sensor circuit. Keep verification separate from testing. After the correction is made, run the same confirmation check again and confirm P16E3 stays gone. The takeaway is simple. For P16E3, do not jump straight to a module or sensor. Check the battery sensor terminal condition first, prove the power and LIN circuits, isolate anything connected to the LIN line, and only then make the final call. For more diagnostic training, visit stepdiagnostics.com.